Very good afternoon, sir.
Good afternoon, everyone. Good afternoon.
How are you, sir?
How are you guys?
Sir, we are good. How are you?
Yes, ma. We are. I'm good. I'm good here. Yes, guys. Um, so how was the day one class? Did anyone try to download the virtual box? Has anyone tried installing the operating system? Uh, the students who are having laptop.
Sir, actually, I'm facing a little lags in my laptop, so I
Okay.
won't be install the software.
Okay, not a problem. Not a problem. This is only for a simple homework. So once our college reopens, we'll be working with the actual Raspberry Pi. No need to worry. You guys don't have to worry, but um, just attend the classes properly so that you'll get an idea of the overall go through of Raspberry Pi and what are all the things we are going to do with the Raspberry Pi and everything.
Of course, sir.
Yes, guys. So I've taken this new device. It's called as Avnet. It is one of the Microsoft development board. So if anyone is having access to the Element 14 website, so you can also order it. So this is available for available as a development board, and cost of this is only 600 rupees once you log in from your student ID. For non-students, this will cost around 5,000 rupees. It has got a very tiny industrial board. Can you guys see this? This is a Microsoft Azure Sphere board. So we can start working with this with our Microsoft Azure platform.
Sir, is it similar to Raspberry Pi 4, or is it like little bit different from it?
This is different from Raspberry Pi. This is a much lower version than Raspberry Pi. This is like equivalent to your Arduinos.
Okay.
So guys, don't waste your time whenever you're in home. Try working with different types of boards. And I have even tried working on this new board. This is called as Odoo. This is much more powerful than Raspberry Pi.
And so what type of OS does it support?
Odoo supports Linux OS.
Okay, like Ubuntu.
Yeah, Raspbian is also a Linux one.
Mm-hmm. So in this microcontroller like Raspberry Pi, we are facing some technical issues, some hardware issue.
Like what?
It's like the overheating of the CPU. If we work like multitasking on this Raspberry Pi or on different software, the Raspberry Pi like is heat up very fast. Even we can't see processor.
Okay, see, we see over here, this is the processor over here. Okay, we'll get a small device which acts like a kind of a coolant that will be available only for 10 rupees or 15 rupees in the if you go to the market IoT shop. Okay, you can stick on that with the help of a thermal cooler or thermal paste.
Like the heat thing.
Yeah, to reduce the heating, you'll get something called as thermal paste.
Okay.
Okay, and you'll get that device called as CPU coolant for Raspberry Pi or for Arduino. It's a very small aluminum device. So just apply thermal paste and stick that device on the processor. So your device will function properly, and it's going to also reduce some amount of heat.
I will try the best.
Yes. And here is my treasure box. This has got almost 37 sensors in this. Okay, guys, it's almost 2:11, so almost all the students are here. So let us start with our today's class, and let me tell you what I'm going to do in today's class. So today we are going to learn about the Raspbian operating system features, and we are going to also start working with the file structures with the help of terminals. Okay, so now all of you just mute yourself, and I'm going to start the class. In between, if you're having any sorts of doubt, you can please raise your hand and I'll clarify the doubts. Okay. Yes, just tell me whether is my screen visible to you and is my voice audible? Okay, thank you. Hello everyone, welcome to day 2 class of the programming board Raspberry Pi. In our previous class, we learned about different components of Raspberry Pi and how we are going to interface with the input and output devices, and also we learned about the operating system which is going to be loaded into the Raspberry Pi called as Raspbian OS. And we also learned about different slots which are available for us for interconnecting keyboard and mouse, as well as the output devices through HDMI and 3.5 mm audio jack. The Raspbian OS, which is also called as NOOPS, is first loaded into the micro SD card, and this micro SD card will be inserted into the slot which is provided by Raspberry Pi. Once it is inserted into the slot, so the operating system is ready to boot. We are going to connect all the peripheral devices to the Raspberry Pi, and we are going to start installing the operating system inside the memory card, and all the sufficient plugins will be installed so that the Raspberry Pi will be ready to boot as well as run the applications on the Raspbian OS. So we also learned about different applications of the Raspberry Pi, where we can convert an old TV into a smart TV, or any old non-communicatable devices can be converted into communicatable devices with the help of the small mini computer. And in our previous class, we also learned about the VirtualBox and the Raspbian Jessie operating system, where with the help of these tools, we installed virtually on the desktop or on our laptop, so that the Raspbian operating system will be available for us to work, simulate, and run the applications which are required for us to interface at the industrial scale. So today we are going to go through this operating system and let us see what are all the applications and what are the options which are available in the Raspbian OS. Oh, this is your day one. Oh, I'm extremely sorry. I'm extremely sorry. I'm extremely sorry. I thought today is your day two. Extremely sorry. Hello, everyone. Welcome to IoT 3 Smart Industry. Industrial connectivity. We are experiencing a very big transition in the industrial technologies from industry 3.0 to industry 4.0, and later on we'll also be seeing the industrial 5.0. The potential benefit of smart industrial connectivity includes improved productivity, improved analytics, and the transformation of the workplace. While connectivity and data acquisition are imperative for IoT, but they are not the end goals, but rather the foundation and path to something bigger of all the technologies. I welcome all of you to the Smart Industrial Connectivity. Let us begin with a small introduction.
In a rapidly changing world, with more interconnected devices than human beings, industrial automation is facing a fundamental shift. It's becoming more flexible, open, and increasingly interlinked. Hierarchical structures are being replaced by cyber-physical systems. So, what's next? Imagine enhanced performance through real-time execution using standard and high-level programming languages. More freedom of creativity by easy integration of open-source software. Or a connectivity solution providing cloud services which integrate actual and future standards, empowering you today for new Internet of Things-based business models. Imagine expanding your development horizons, having differently skilled programmers work all on the same project, all conveniently using their favorite programming tools.
Before we start with the IoT 3, let us have a small briefing of what we have done in our previous IoT 2 program. So in the IoT 2 program, that is communication and protocol, we learned about a device called as Node Microcontroller Unit, which is manufactured by Espresso. And we learned about the complete architecture of ESP32. And we also learned the complete system on architecture, or system on chip architecture of ESP32 devices. We learned about the protocols which can be incorporated inside Node MCU, and we also had some practical implementation of using the Node MCU with the sensors such as temperature and humidity sensor. And then we did a practical of connecting the Node MCU to the cloud, that is Firebase. And then we also did a small homework on building an MIT App Inventor application through which we were capable of sending the data with the help of Firebase Cloud. And later on, we also had a lot of knowledge gain on the IoT applications. Especially, we learned about the protocols and standards, where we learned about HTTP and HTTPS protocol, MQTT, COAP, XMPP, and DDS. So let us go to the advanced level of the program, which is our IoT 3. And now in the IoT 3, we are going to see how our program structure is going to help us in the major transition of industrial automation as well as industrial connectivity. Now, how all the program what we are going to learn in this IoT 3 is going to be incorporated at the industry level, and what are all the industrial applications we are going to use, example ThingWorx, and the applications of the different industrial projects. So we are going to have an example and the application of how the industrial connectivity is going to be used at the large scales.
What is industrial automation? Automation is the use of machines to carry out manufacturing processes with little human involvement. Industrial automation allows for facilities to utilize these processes for a more optimized operation. Manufacturers use machines that are operated through different control systems, like programmable logic controllers or PLCs, human-machine interfaces or HMIs, and robotics. Automation uses logic and programming to feed the machine information on how to carry out a function. These machines allow for high control, which improves manufacturing performance. There are a few different types of industrial automation systems. Hard or fixed automation is made for repetitive tasks with high turnout rates. Programmable automation is used for batch production, where the automation process can be modified. Soft automation allows for flexibility and changes to products quickly and easily. Some of the benefits of industrial automation in a manufacturing environment include high reliability, increased productivity, quality enhancement, and reduced labor expenses. Industrial automation in a manufacturing environment may include various types of equipment. Automated material handling systems such as Swisslog AutoStore are specialized, autonomous, and compact in size for fast inventory retrieval speed. These systems are customized for the environment and needs of the facility they are housed in. 3D printing machines allow manufacturers to create 3D models of particular items from a computer. CNC machines come in many varieties. To learn more about various types of CNC machines, visit the link in the description below. CNC machines can take material and reconfigure it into a precise form within the operator's given measurements and requirements. Robots complete repetitive and mundane tasks. These types of tasks can easily be programmed and given to a machine to perform.
Yes, in this video, we learned how different CNC machines, how different robots can be programmed. Now, the biggest question over here is how it can be programmed and how we can make these mechanical devices actually work as per the task assigned to them. Now, all of this is possible by programming the information or programming the commands into the programmable logic controllers. Yes, these are the microcontrollers which is going to carry out the major and complex task of assigning different programs to the machines. So in industrial connectivity of IoT 3, we are going to start with the basic programming board, which is called as a Raspberry Pi. And then once we start with the understanding of the hardware of Raspberry Pi, we are going to learn about the Python programming. So on the Raspberry Pi, we are going to use an operating system called as Raspbian OS, and we are going to also install the Python libraries along with the Python softwares, where we are going to start learning about the Python, which is necessary for running the IoT applications and also interfacing with the sensors. So once we done with the Python programming, then we are going to have the understanding of the ARM processes, ARM, which stands for Advanced Risk Machine. So here we are going to learn about different version of ARM microcontrollers. And also we are going to learn the key aspects of how the ARM processors can be used for giving different IoT solutions. Now, once we are done with the ARM processors, then we are going to start understanding about the gateways. So the Raspberry Pi itself acts like a gateway once we configure it properly. And not only the Raspberry Pi, we are going to also learn about different industrial gateways which can be used and how these gateways are going to function. So once we are done with the gateways, then we are going to start working with the connectivity part, where we are going to divide the connectivity into large scale and small scale, or to be more precise, the RFIDs and Bluetooth, as well as GSM and 3G and 4G networks, which is the short range and long range communications. Now, once we are done with the communication part, we are going to next go to the cloud services. Now, in the cloud services, we are going to learn about the infrastructure level and platform level, as well as software as a service levels. So there we are going to take an example of the AWS cloud as well as Microsoft Azure cloud in order to incorporate the applications with the Raspberry Pi. So once we are done with the different levels of cloud, so next we are going to go with the data management. So here we are going to learn about, once we start collecting the data from different microcontrollers, now what do we have to do with this type of data? How do we collect this? How do we organize this? How do we filter the data? So here we are going to start working on AWS S3 storage and AWS RDS. And we are going to also learn about the different data management tools which are required for IoT. So after the benefits of data management, next we are going to go for the different communication channels through which we are going to send the data from source to destination. So this is where we are going to learn about the GSM service, and we are going to also learn about different PLCs, Wi-Fi, 2G service, 3G services, and we are going to also learn about LoRaWAN, which is very much essential in terms of understanding and incorporating our own communication channel with a specified bandwidth. And finally, we are going to learn about the interfacing platform, which is called as ThingWorx, where we are going to interface the hardware with the software with the help of industry level APIs, which is provided by ThingWorx. So what are the objectives of our program? When we start learning about the industrial IoT 3, which is connectivity, industrial connectivity, we are going to go through different types of technologies. Now, as we start learning these different type of technologies, we are going to start giving out the outcomes of all the technologies what we are going to learn, and we should have a proper objectives regarding what if I study the IoT 3, what would be the outcome, and what is the scope of learning the IoT 3 program. That means once our entire program is done, where exactly you guys are standing and how the companies are going to view you at the end of the program. So at the end of the program, you guys will be a very good IoT designer or an IoT developer or an IoT analyst or the IoT tester. Now, any one of these designation will be suitable for you depending upon how much you have incorporated the whole technologies. So before we go to the actual learning of the IoT 3, we are going to brief you about how we are going to incorporate all of this technologies, what we are going to learn in smart industrial connectivity into the real-time application. Yes, now we are going to start with one of the real-time project, which is called as smart public transportation. We are going to provide you a battery operated rickshaw where we are going to give you certain amount of problem statements such as what is the battery level, how much passengers are sitting in the vehicle, what is the distance traveled by the vehicle, and at the available battery charge, for how long the vehicle can travel, and also the information regarding where exactly the vehicle is located and at what speed the vehicle is moving. And we are going to also perform one of the operation where we are capable of checking whether the driver, we call it as driver drowsiness. So we are going to take the input in the form of pulse rate of the driver, and we are going to perform pattern analysis or pattern recognition in order to see whether the driver is fit to drive the vehicle or not fit to drive the vehicle. So this is a very interesting project where we are going to incorporate in real time. So not only the smart vehicle, but we are having several other industry ready projects which we have done in our internship program, which is called a smart water management. So we are going to implement this in the real time. Not only the smart water management, but along with we have several different problem statements. Along with water management, we have smart medical box, smart street light, smart transportation, smart army watch, and this will be a very interesting project, smart army watch, and the smart patient health monitoring devices. Let us start with the industrial connectivity. So industrial connectivity is explaining or is trying to give us a picture of how large in terms of scalability the sensors and the microcontrollers and the PLCs will be incorporated with different types of machines, and how the PLCs and the microcontrollers are capable of sending the information in terms of controlling and coordinating all of these devices so that all the machinery has to function together. Now, we have seen in the industry there are huge amount of robots which are performing different types of tasks. Now these robots are pre-configured where a human or a developer has to send certain commands or give certain commands which is going to tell the robots under what speed, under what distance, under what devices and the object the devices has to or the robots has to function. So robots basically has completely transformed the overall production cost and the overall production time which is required by the manufacturing plants to do a task. Now the problem with the robots is the robots has to take certain amount of commands from the user. Now just think over this. How about we make this robot intelligent by using machine learning and artificial intelligence so that by performing data analysis and analyzing the data, the robots can actually give you a conclusion, or the robots can actually decide what to be done and what not to be done. Now, by having this intelligent robots, it is going to improve the overall cost effectiveness and also the industrial grade to a next level. Here is a small pictorial representation of what are all the different segments we have in an industry and in an actual working industry. So we have different segments where one of the segment actually deals with the communication and the connectivity, and the other one deals with the remote assistance and computer vision, and there is a segment where which is going to completely deal with the protocol gateways, which device or which machineries are connected to which particular communication devices or networking devices with the help of gateways. Then we have data analysis segment where we are going to collect data, and all of these data which are coming from the machine will be analyzed in such a way that whether the machine is functioning properly, whether the machine is fit enough to do this task. When the machine was started, when the machine was closed or stopped functioning. Now, all of this analysis can be done by collecting all the data from the microcontroller and the PLC devices, and we call this as data analysis. Now, in the data analysis, once the analysis is done with the help of edge computing, next is the assessment part and the asset tracking part. Now, this is where we are going to assess whether the product what we are manufacturing is in a proper defined objectives. And also, all this products which has been designed will go for the next stage, which is called as packaging and delivery. And this is the overall overview of how an industry functions at large scales. Here is a small video of how exactly the overall process is done, and we can visualize this and we'll get an idea of the functionalities.
In industrial operations, siloed data can be your worst enemy, leading to inefficiencies, miscommunications, or even worse, downtime. Ask yourself the following 3 questions to learn if your industrial ecosystem is maximizing data connectivity. Question 1. Is your data timely? Does everyone across your manufacturing enterprise have access to real-time data? If not, you're likely missing out on optimal data visibility, faster decision-making, and advanced warning of production changes. Question 2. Is your data integrated? Does all your data come from the same source? Siloed data creates more work for employees and decision makers alike and prevents integrated views of the entire industrial ecosystem. Question 3. Is your data easy to manage? Do you have a scalable and intuitive data management system? Without simplified means of using your data, you're wasting valuable time and resources across the enterprise. Accessible real-time data presented in an integrated, user-friendly data management solution can transform your plant floor. To learn how you can maximize operations and do more with what you have in your existing industrial ecosystem, download our ebook at kepware.com/improve.
Yes, there was a small overview from our PTC website, which showed how the industrial connectivity is actually done by using the ThingWorx platform to interface the hardware and the softwares. So let us start our program with one of the very important development board, which is Raspberry Pi. So we have come across Raspberry Pi in our different technological words of exchange, how Raspberry Pi can be used for projects, how Raspberry Pi can be used for programming the devices, how Raspberry Pi is capable of actually functioning as a small computers or portable devices, which is of only a pocket size. So the incorporation and the flexibility of Raspberry Pi is very huge. Why? Because Raspberry Pi is not only a microcontroller, but is also a small computing device. And one of the most important thing, it is low cost computing device. So we can start using Raspberry Pi in multiple projects by interconnecting the input and output IO devices along with the GPIO pins with different sensors. So Raspberry Pi can be used at or an average or a medium scale of computing, where we can perform word processing, we can perform a small level of audio and video processing, play a small level of games, and browse the websites. So basically, Raspberry Pi acts like an pocket-sized computer, which is going to perform multiple tasks. So Raspberry Pi has a wide variety of applications in the outside world, where this Raspberry Pi can be used to model some of the applications Now, before we go to the modeling of the applications and actually incorporating the Raspberry Pi at the industrial level, let us have a small virtual tour of the Raspberry Pi and how exactly the device looks, how exactly it functions, and how it can be interfaced.
So you've got your first Raspberry Pi, you lucky thing. But now what? Well, fear not, adventurers. I'm here to explain all. The Raspberry Pi is a tiny computer that has the ability to do loads of wonderful things. So, let's take a closer look. For a keyboard, that's what these USB ports are for. Oh, wait! There's also an HDMI port for a display. You can use a monitor or even your family TV. And this is an Ethernet port, so you can connect to the internet. Your Raspberry Pi even has a connector for a special camera module. It can hook up to lots of other devices if you use a USB hub too. So now we've had a look around the Raspberry Pi, let's get set up. First, you're going to need a screen. This can be connected with an HDMI or analog cable depending on the kind of display you're using. Next, a USB mouse and keyboard. A micro USB power supply, like one you use to charge your mobile phone, and an Ethernet cable to get online. The operating system runs from a micro SD card, just like the one in your digital camera. You can download your operating system for free from the Raspberry Pi website. If you want to get started even quicker, you can buy a Noob's card which comes preloaded with a choice of operating system for everyone, from beginners to experts. And there you have it. Your shiny new Raspberry Pi is ready for you to boot up and start doing fantastic things. Build an arcade machine. Make a robot. Create music. Fly a drone. Or send your Pi into space. So what are you waiting for? Go on, make your Raspberry Pi do something truly amazing.
Yes, the use of Raspberry Pi at the application level is completely endless. There are huge amount of projects we can do with the Raspberry Pi. So here is a simple architecture of Raspberry Pi, which is showing several different components. That is the input and output component, the memory structure, processor, and the GPIO pins, along with the networks. So the Raspberry Pi consists of an SD card slot where we are going to insert a SD card for actually loading the operating system and running the operating system. Then we have USB port for attaching keyboard and mouse. We have power port. We have 3.5 mm audio jack for connecting the sound cable. Then we have RJ45 network where we can connect a LAN. We have SDMA slots for the output connection. And then we have a special port where we can actually interface with the camera. And finally, the GPIO pins to connect to the sensors. So here's a small animation of how different components are getting connected with different types of input and output cables. So along with the micro USB from micro memory cards till the networking. So how exactly the Raspberry Pi will function? So Raspberry Pi comes with its own operating system called as Raspbian OS. Now this Raspbian OS is available in www.raspberrypi.org, where we call this operating system as Noobs. Now once we download these Noobs, we'll load this Noobs into the micro SD card, and then we'll insert this card into the slot, and once we boot the Raspberry Pi, we'll get an option to load and actually install the operating system. This is where we are going to run different types of applications, different types of programs. Like we can actually browse and do lot many things. So to do all of this, the operating system is one of the important component in Raspberry Pi. So the Raspberry Pi, once we start up, so it is not just like your average microcontroller where we can do the plug and play devices. So the Raspberry Pi should be Raspberry Pi is a small computer, and we should be very careful in whenever we are booting the device, as well as when we are logging off from the device or shutting down the actual devices. So it is just like a mini computer, just like how you are going to start your computer and start off your computer. So Raspberry Pi is basically an device which supports a miniature version of Linux-based operating system, which is Raspbian OS. And the process of installing the Raspbian OS is shown in a small graphical representation. And in order to connect and load all of these, we need to have the plug and play devices such as plug and play keyboard, mouse, and we need to have a LCD display in order to view the output. And we should have a memory card where we are going to load the operating system. So now we are going to actually work with the Raspbian OS and all its application on the operating system, on the Raspbian operating system, before we actually go to the hardware part. That means before we actually load the operating system into the hardware and work with the interfacing of the hardware, we will do certain virtual experiment or the virtual practical implementation by using Raspbian OS. Now, I'm going to show you the steps which are required and the tools which are required for us to run the Raspbian OS and start learning about the Raspberry Pi. So here is a website where I'll be sharing with you so that you can directly log in. And once you log in, so the website appears like this. It's called as avoiderrors.com. So we have both the applications which are required for us in order to do this experiment or these practicals. One is the Raspbian Jessie, which is an virtual operating system which comes as an ISO image. And to install the operating system, we need an virtual platform or a virtual environment, and this is done by running an open source tool called as Oracle VirtualBox. Either you can directly download from here, or you can directly go to the website, which is called as virtualbox.org. And I suggest you to download the version VirtualBox 5.2 builds until or unless you are using AMD based processor. If you are using AMD based or any recent advanced level AMD processor, go to or download Virtual 6.0. If you are using Intel based, please go to VirtualBox 5.2 builds. So once you click on this, it is going to give us the option of different versions of the VirtualBox. So the latest one is VirtualBox 5.2.4.2.44. So you can directly click on Windows host, and it gives you the option to store the application. So you can store this application on your desktop. So I have already saved this file, so I'm not going to load it again. And once done, the next step is to download the VirtualBox operating system. So if you go to osboxes.org, the osboxes.org, and select the Raspbian OS, so here we have all the VirtualBox operating system, which comes in extension of VDI, and make sure you download 32-bit size. So if you click on download of any recent version, so it is going to give you the options to actually download it. So you'll get a window, and make sure you download this into one single folder where you have also downloaded the VirtualBox. So I have already stored this operating system, and I'm going to start showing you how exactly to install the application first. So once you download the application, so we have to first install the application called as VirtualBox. Double click on VirtualBox. It is going to start asking you the setup part. So click next. So it is going to ask you to choose a place where you have to install. So choose a normal C drive and click next. So the whole installation is done. So I have already installed. It is showing me a different option. So once you install, the application looks like this. Yes. So your application looks like this, and if you are using 5.2 version, it will be asking you to upgrade or update the version. Please do not update it. So make sure it is retained in 5.2 only. Do not update to 6 version. So once you start the application, the opening window has the following options over here. We have new settings, and we have machine tools, global tools. So go to the new, and it's going to ask you what type of operating system name you are going to give, which you are going to run on VirtualBox. So I'm going to give it as Raspbian Jessie. So as soon as I gave Raspbian Jessie, it has selected the default type, operating system type, and the version. So type is Linux, and it has selected Debian 32, or this also functions if you choose Ubuntu. It's your choice. Either you can choose Ubuntu or Debian. So click next, and it is going to ask you how much memory space is required. So in the original Raspberry Pi, the RAM size is 512 MB. So here it has allocated 1024 MB, which is more than sufficient. So click next. Next, it is going to ask you what type of hard disk it has to choose. So here it has by default taken a create a virtual hard disk now. So click on create. Yes, make sure we are going to select the first option, VDI, VirtualBox Disk Image. Next, storage on physical hard disk. So make sure the option dynamically allocated is selected. Then once done, it is going to ask you how much hard disk space is required. So by default, it has taken 8 GB. 8 GB is not sufficient. Please make sure you choose at least 16 GB. So once you select 16 GB, click on create. So our virtual platform to run the Raspbian OS is created over here. Yes, guys. So in today's class, we learned till how to install VirtualBox and also how to configure. In our next class, we are going to learn about how to install the Raspbian OS on VirtualBox. Okay. So if you're having any doubts, please clarify now. You're free to ask the doubts. Something you're feeling any difficulties over here, I'll clarify now. Yeah, ma, I'll share you this video. I'll share you this video on WhatsApp group. See, I suggest you download version 5.2.44. Do not download 6.0. It will not support. it is safe to download 5.2.44. Okay, guys, so let us meet in the next class. Next class will be even more interesting. We are going to learn a lot many things about Raspberry OS. So till then, thank you everyone. So I'll be sharing this video in your WhatsApp group. You can also review it again. Thank you so much, guys. Bye.